The parabola, finding the equation of the circle. Well, the parabola we kind of shortened a little bit, but when you did the circle, didn't that look all familiar? And sometimes, sure it did. You had like the B, E, and N. This was out, the A and the B. That might have looked a little bit different there. But we found different parameters that were missing. So they all kind of fit that format. Now, I know you've dealt with parabolas before, and generally they look a little bit different. They look more like your quadratic. But we're going to change the equation on them a little bit. Normally, they followed your equation, and then you even put it into a vertex form. This was your vertex form. Remember your vertex form? So this is kind of similar to your vertex form, but we're changing this. Now, the reason we change this is because we want to find two other things about your parabolas. We want to find your vertex as normal, we want to find a focus, and we want to find a directrix. So what that means is this. If this is my parabola that goes up and down, if up and positive, down, negative, your focus is a point that's going to come inside your parabola. It's going to be on the same vertical line or horizontal if it opens sideways as your vertex. A directrix is a line that is also equidistant from that vertex, but it's outside your parabola. It's not going to cross through your parabola. So in college, they'll generally look for focus and a directrix. So to do that, we put it in a little bit of a different format. Now the one thing that we have to worry about is this P. And as many formulas as I give you, don't memorize them. We're going to work them with your sketches rather than with your formulas. I always get one or two kids that like the formulas, but notice, and as we go through this, it's the same letters. You just got to worry about who has, was it Y equal, who has the K, who has the H. The H is always with the X, the K is always with the Y. But then you have to figure out which way you're going anyway, so we're going to use your sketches rather than the formulas. They look a little scary right now, but they're really not that scary. The one that's squared in a parabola, there's only one variable that has a square. Only one variable is squared. That's how we know this is a parabola. In a circle, both variables are squared. In a straight line, neither variable is squared. In a parabola, one variable is squared, which is why you get your quadratic format. So we're going to be putting everything into this format. We can pull out the vertex. This is your HK. We can find the P, and from there we can sketch a focus point, and we can sketch a directrix, a line. So as scary as it looks, keep this thing around you. I gave you kind of like a little look of what they both look like. I couldn't fit this all on one page though when I was trying to pull it up here. So I gave you a couple of examples here. I thought it'd be easier if you looked at it. In a vertical axis, if that's your normal x squared, when P is positive, greater than 0, positive, your parabola opens up, your focus is inside, always, your directrix is outside. When P is less than 0, negative, your parabola opens down, your focus is inside, your directrix is outside. Now the ones you guys are probably not familiar with are the y-squares. Y-squared works the same way, only it opens left and right. If it's negative, it's going to open towards the negatives, left. If it's positive, it's going to open towards the positives, right. And again, don't get hung up on the formulas. You'll figure them out as we go. So let's work this one together. Okay, so the first thing we're going to do is, which one is squared? The y. So it's either going to open to the left or to the right. So since it's a y squared, we're going to just follow your formula to set it up like this. We're going to follow this formula. We're going to keep this guy right here, and we're going to send this whole thing to the other side. Okay? Now, the most important part is this piece right here. This piece is your 4p. Because this says 4p x minus h. If you line this up. The p, remember, if it's negative, will tell us if it's left and right that we open left. The vertex, we still find x is always with the h, the y is always with the k. So what's your vertex for this guy? And it always comes out the opposite way. So what's the vertex going to be? -3. This would be your k. -3, opposite way, 2. Because if you look at this, -2 is equal to -k. Therefore, positive k is equal to positive 2. It's like the circle. It always comes out the opposite way. So we have a vertex. Now, this is the important part right here. -1 is equal to 4p. So if I divide both sides by 4, then my p is -1/4. Now, when we go to sketch, you start with your vertex. So your vertex says -3, +2. This is my vertex. Remember, it's a sketch. It's going to open to the left. Tomorrow we're going to add intercepts because we don't know how wide it's going to open. We know it's going to open left because p is negative. So it's going to open left. Tomorrow we'll add the intercepts. Today we're just going to go like this. Now, we have two things of interest, a focus point and a directrix line. At directrix, is that going to be an x equal or a y equals? X equals. Isn't it cutting it through an x point? X equals. Now, we're going to use our graph. We're not going to use your formulas. You can if you like to, but if you use your formula, you're going to have to say to yourself this. This is a y squared. I have to go to my y squared part, which is my right side. I'm going to take my vertex, which is an hk, and I'm going to add and subtract from the hp. So I'm going to do an h plus p to get a k, and an h minus p to get the directrix line. So rather than worry about all this, we're just going to do this by eye, which makes it a lot easier. This is on the same axis, this focus, as this vertex is. So if this is my point for my vertex, am I changing my x or my y if I move to the left? X. So the value of p, 1/4 to the left. So if this point is -3, 2, and I want to move to the left 1/4, what's my focus going to be? -3 1/4, 2. So you might want to change that to an improper fraction. So this will be -12 plus 1, 13/4, 2. There's my focus. My directrix goes the other way, and we had an x equal. So all I care about is the x that's changing. So if I go this way 1/4, what would my x value be? If I have to subtract a quarter, I have to really kind of take a quarter away and go this way. I would be at what point? -2 and what? 3/4, right? So if you want to turn this into an improper fraction, -8 plus 3, 11/4. There's my directrix. There's my focus. There's my directrix. I'm at -3. I want to go 1/4 away. So kind of just like work out the numbers. It's got to be less than It's got to be less than 3, right? Because I'm not going to hit -3. I'm going to be before -3. So it kind of has the opposite effect. If you put this into your formula, it will have the opposite effect because P is negative. So instead of subtracting P, you would be adding P. Instead of adding P, you would be subtracting P. So instead of going through that, we just eyeball this and we can figure it out from here. If P was 1, so if I drew this thing, maybe if I did this and P was 1, let's take a look at this for a second. Here's your vertex point. It's going to open left. So say, for instance, I want you all to understand this, so maybe you're having a hard time with the fraction. Say P is equal to -1 without a fraction. What would my focus point be? It's -4. Don't I move 1 over right to the left? It's forcing me to move to the left. And what would my directrix line be? -2. X is equal to -2.
So how do you find P?
P is this piece right here in front of that parentheses.
Okay, but from the original problem, how'd you get that?
Because the original problem, everything was on one side. So our format says keep the square on the left side, put everything else to that right side. So I kept my square here and I moved this entire quantity and subtracted it to here. So it said negative x plus 3. So I put a little -1 there because that's the number in front of that parentheses. That -1 is equal to 4p. Okay? Now, you're probably being a little bit thrown off with the fractions, so hang in there with the fractions. Okay? So here's another one. Now, you all know what this looks like, right? You all know what this guy looks like. It's a parabola. Where does it open? Up. What's its vertex? This is your normal quadratic.
0,
Uh-huh. So it's going to go like this. Little stretched out, a little stretched this way because it's a dilation of 2. Instead of being wider, it's going to be a little bit narrower. So let's put this in our format. Let's reflect this guy first. I'm reflecting it because the square goes on the left-hand side. And you notice your vertex is 0, 0, right? Because doesn't it look like this? We really don't need the 0, 0 in there. But we do need to get rid of that 2 in front of this x squared. That has to be by itself. The square has to be by itself. The only number that comes out is this guy here where the p is. So how do I get rid of that 2? Divide by 2. So if I divide this by 2 and I divide this by 2, this gives me x minus 0 squared. I'll take the 0 out in a second. Just pull out this fraction. So we decided that our vertex was 0, 0. So let's take this out. Good so far? So we're going to say that this guy right here is equal to 4p.
2p.
So what?
Oh, sorry.
How am I going to get rid of the 4? Divide. So that says keep, change, flip. So what should p be?
1/8.
1/8. Okay, let's sketch this guy. We're going to get the same graph. We just can't find a focus and a directrix from our quadratic. So again, we said that our vertex was at the 0, 0. We said that it opened up. Same exact graph we got before. But now we say we can find a focus and a directrix. Which value is going to change when I move up and down, the x or the y? The y. So if this point right here was at the 0, 0, and I need to move 1/8 up, what will my focus point be? 0. I'm changing the y, 1/8, right? Now, what kind of line is this, a horizontal? Is it an x equal or a y equal? A y equals, good, because now when I drop down, what am I changing, the x or the y? The y. So I'm dropping down how much? -1/8, good. So there's my directrix, there's my focus, we know the vertex, and doesn't the graph look exactly the same as when you graphed it as a quadratic? But if you left it in that format, could you find a focus and a directrix for me? If it was in your quadratic format? No. You could still graph it. It's a heck of a lot nicer to look at, I get it. But the problem is, you can't find a focus or a directrix without the P. So it has to go into this new format. I realize it's a little different than we normally look at. Questions? Okay. I think that was it for that. Do you want to try one on the homework? Maybe that will help a little bit. Pick a nice juicy one on the homework. Now, these guys, you're basically matching. You're matching to the graphs. Easiest way is like your y equals, your y squares. Which way should this one open?
No, raise to the right.
Nope. What's P going to have? A negative sign. So where's it going to open? Left. Where's this one going to open?
Right.
It's an x squared, so x squared can only open up and down, and P is negative. Down. Follow my squared. So a y squared is either going to open left and right, and P is positive. Good. It opens right. X squared opens up or down. P is positive. Opens up. And a y squared, left or right, when P is negative, opens left. Good. I've got an x squared, it opens left or right, and P is positive, P is negative.
Opens down.
Opens down. Now you might have one that, that you can look up, you can find the vertex. Most of them you should be able to find. One with a larger number will generally be a little bit wider. So that part you can do. So let's drop down and pick one of these little doozies. Let's do number 72. 72 good? Well, which one would you guys like to do? I can give you a lot. Just to get used to this.
72 is good.
Okay, let's take a look at 61. 61, let's put this in your format. Always get the square to the left-hand side. This is reflexive, so just reflect this. The x squared side can't have any coefficients. So how am I going to get rid of 1/2 there?
Dividing on both sides.
Divide by 1/2, or I can what?
Multiply.
Multiply by 2. So now, which way is this going to open? Up. This guy is going to be your 4P, and you can do the rest of that, right? Okay, so which one do you want to do? 72. Let's walk this one through. I got the square on the left-hand side. I've got the other part on the right-hand side. So which way is this going to open? Opens up or down, or left or right? Up or down, it's x squared. And when P is positive, it's going to open up. How do I know P is positive? Because this little guy has to be equal to 4P. Therefore, what is P?
1.
1. Okay. What's my vertex?
1 negative
H goes with the X.
1 no negative 1.
Negative 1/2, 1. Your vertex is always HK. Okay. So I start by graphing this. Negative 1/2, 1. And which way is this opening? Up. So I'm going to make a little bit of an up thing like this. Okay. This is my vertex. Negative 1/2, 1. Remember, we're sketching. No tick marks. We're sketching. We need a focus that comes inside and a directrix. Oh, I didn't put the ink on. And a directrix that comes outside. So before we move the directrix line, let's figure out P is 1. So let's move this up and down. When I move up and down, does the X change or the Y change?
Yeah.
The Y. So what's my focus point going to be now? 2. So it's going to be negative 1/2, 2. If I drop 1, where will my directrix end up being? If I take 1 away from that Y, at the 0. So where's my line? Right here. X is equal to 0. This is my directrix. I just happened to fall right on top of the x-axis. I'm sorry, y is equal to 0. I happen to fall right on top of the x-axis because I dropped 1 down. Any horizontal lines are y equals. Any vertical lines, x equals. Good? Questions? I know this is not a format that you particularly care for. No, but it follows the format that I gave you on the sheet. Don't use the equations. Did I use any of the formulas? Nope, we use the graph. Determine which way it's opening. Is P positive, negative? Is it x squared, y squared? Find the value of P, and then you can find your focus and your directrix. So you guys can do the rest of your homework.